And here we are. Okay. Oh, did I? No, I did not. Son of a gun. Okay. All right. So, does the type or the number of particles affect colligative properties? Well, you know dang well that the definition of a colligative property is based on the number of particles and not the type of particles. If you want to add a gas to a liquid, what two things could be done to increase solvation? Well, we know what it looks like. We know what the solubility curve on a gas looks like. So we want to keep a low temp. And the other part of this equation is if I'm trying to put CO2 into Coke, have you seen those tanks? Have you seen those tanks that they use to put CO2 into Coke? Do those strike you as being low pressure tanks with these blow off valves and all this big knobs and steel tanks, or do they strike you as being high pressure? The answer is high pressure. Low temp and high pressure. It's the same thing like a pressure cooker. A pressure cooker basically you can heat up water more than 100 degrees because the vapor pressure, it can't vaporize anymore. So the water gets hotter than 100 degrees. The more pressure you add to it, the more you can keep things in solution. So if I add a bunch of pressure into this container, kind of looks like a rebreather or an oxygen tank for a scuba diver. But if I add this is my can of Coke, or in my case, a can of Pepsi. I'm going to use Pepsi because I just want to make everybody mad. Pepsi. And I want to drag this video out a little bit longer. If I'm trying to pressurize, I'm going to use a high pressure, and I'm going to keep this cold, right? I'm going to keep this ice cold, so 0 degrees Celsius or something like that. I don't want my liquid to freeze, so actually I'm going to say 1 degree Celsius. And I'm going to use high pressure. So the atmosphere is 1 pressure, that's 14 psi. So I'm going to do 2 atmospheres. Yeah. So 1 degree Celsius, 2 atmospheres to put CO2 in my Pepsi. Vinegars can be 5 to 20% acetic acid solution and has been used for medical purposes for thousands of years. If a person takes 2 tablespoons of vinegar a day and the molarity of the vinegar is 0.84, then how many grams of acetic acid will be consumed? And 1 tablespoon is 15 milliliters. Here's the problem there. They don't specify a time period. If a person takes 2 tablespoons of vinegar a day, are you asking me about how many grams of acetic acid will be consumed in a week? Are you asking me how many grams will be consumed in a day? Are you asking me how many will be consumed in a year? Are you asking me how many will be consumed in a bajillion years? I hate ambiguous questions like this. But since we have some answers, I'm going to assume they're saying in a day. And so we have 15 milliliters. Basically, this is a molarity problem. They've given us a molarity. And they're asking us to figure out how many grams. Okay, so let's do it. First, we got to figure out how many moles. So 0.84, they take 2 tablespoons. Wait a minute. 2 tablespoons a day. Each tablespoon is 15 milliliters. That's 30 milliliters. I'm going to convert that into liters. Divide it by 1,000. That's 0.03 liters. I have a molarity target. So 0.84 molar equals 0.03 liters. X moles, right? Oops, sorry. X moles, 0.03 liters, 0.84 molar. Let's not be bad and not do our units. So X is 0.3 times 0.84 equals 0.252 moles. And then I got to convert moles to grams. So 0.252 moles of okay, 0.252 moles of HC2. Okay, so we're gonna do 1 mole. We're going to grams of H2. Oh, sorry, HC2. Oh my God. Let me just add this up really quick. We have carbons times 2, hydrogens times 4, oxygens times 2, I've added this up wrong. I know I have 12 times enter, plus 4 enter, plus 16 times 2. I'm sorry, I'm getting tired, guys. 60 grams per mole of HC2H3O2. So 60 times 0.252 moles equals 15.12 grams. Do I see that answer on here? Nowhere on here. Absolutely nowhere on here. I see a 1.51. Have I misstated something here? 60.252, 0.03 molar. I mean, sorry, 0.03 liters. 15, 30 milliliters. I don't know what I've done wrong here, guys. I don't know what I've done wrong here. 0.252 moles. Let's see. 0.84 molar. I see that's right. 0.84 times. Oh, I see what I've done. Okay, my 0.03, I entered 0.3, so I'm off by a decimal place. Times 60 equals 1.512. Here's my answer, 1.512. See, 1.512, and somewhere up here, instead of multiplying times 0.03, wherever I did that, I did it incorrectly. Anyway, so it's 1.51. A student wants to determine how different factors affect the rate of blah, 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 blah. I'm just going to read the answers and see if an answer makes sense to me. Investigation 1, 2, and 3 are needed for testing temperature, surface area, and agitation of the solute. Okay, this is a stupid question already. Investigation 2 and 3 are needed since 1 is the same as investigation 2. Well, let's see if that's true. No, the temperature is kept steady in investigation 2. The temperature is not kept steady in investigation 1. Investigation 3 is not necessary since the same results will be produced by investigations 1 and 2. Not without stirring, it won't. Investigation 1 is the only one that is needed. Investigation 2 and 3 do not need to be performed. Well, we know that stirring, shake, bake, and break, right? So I need to test the breaking, I need to test the temperature changes, and I need to test the stirring, right? So 20, 20, 40, 50, 20, 30, 40, 50. I'm going to say that I need all three. So I'm going to say that investigations 1, 2, and 3 are needed. I hope that question's not on the test because it seems, and just between you and me, it seems kind of dumb. Okay. Okay. Anyway, I hope all these videos help. I hope if you have any questions, I hope you'll come to me. I hope you won't just write these answers down on your sheet and then go, see what I did, Mr. Irwin, on Monday just to get a grade. Look, your grade's going to be better if you actually do the work, and none of this work is very hard. It's certainly not as hard as doing stoichiometry. All right, guys, I will see you on Monday.